Now let's extend the previous case to three cases here, three levels. So earlier we have seen what happens with two levels. Now the same examples we are going to see using three levels. Now assume that for this one all the levels are connected parallelly to the processor. Therefore processor will start searching for a word in all the three levels in parallel, and whenever it finds a word it will stop the search. For example, if this one, let us say level 1 is having access time of t1, assume that it is less than the access time of t2, it is less than the access time of t3. So what I mean to say is, if a word is present in L1, we will be able to get it fast. If it is not present in L1, or if a word is present in L2, the time required to get it is more compared to time required to get the word in L1. Got it? See, if a word is present in all the three levels, then what happens is you will be able to get the word fastest from L1, which means in that case we are going to get our word in time t1 and stop our search there. In case if it is not present in L1, if it is present in L2 and T2, then what is the faster way I can get it? From L2. Since I am searching in all of them parallelly, I will be able to get the word in T2 time, and that will be the access time, and I will stop it, right? In case if it is not present in these two, then only our access time is going to be T3. Now how to put it in terms of hit ratio? If it is present in this, that is called as hit in L1. If it is present in this, it is called as hit in L2, given that there is a miss in L1, right? So how are we going to use these levels is, we will be using the word from L1 if we are able to find it, which means if there is a hit in L1. If there is a miss in L1, then we are going to get the word from L2, then that is called as hit in L2, right, and miss in L1. Now when do we use the word in L3? If there is a miss in L1 and L2, then only we are going to use the word in L3. Got it? Okay. Now if you observe this, how we put it is, if there is a hit in L1, which means H1, those many times our time will be only T1. Out of 100, if these many times I am able to find it in level 1, then the time will be this much for those many times. In case if it is not present in level 1 and if it is present in level 2, which means it is missed in level 1 and it is present in level 2, then our time is going to be T2 for all such cases. And what is the third case? It is not present in L1 and it is not present in L2, then only we are going to get the word from L3. In that case the time taken is T3. Therefore in this case, in worst case, if a word has to be received, what is the worst case time? Worst case time is going to be T3. What is the best case time? Best case time is going to be T1. Therefore in this case, if you observe it, T1 is less than T average is less than T3. I can put less than or equal to, which means our average access time will never be beyond this and it will never be less than this. Got it? So in best case, what is the access time you are supposed to get? It is equal to T1. When do you get that? If all the time we are going to get the words in the level 1, which means if H1 is 100%, out of 100 times all the 100 words are present in level 1 only, then it is going to be H1 into T1, which means 1 into T1, and this one is 0, this one is 0. That is the best case. What is the worst case? It is not present in, no word is present in level 1, which means H1 is 0 and no word is present in level 2, which means H2 is 0. Then this one is going to be 1, this one is going to be 1, and this one is T3. And also one more thing, if you observe it, we are not talking about the hit ratio of level 3. H3 is not given. Why? Because H3 is always 1, isn't it? If you assume that there are only 3 levels in the computer, then the word you are searching for should obviously be present in the last level, otherwise we don't search for it, right? Therefore the hit ratio for L3 is always assumed to be 1 in case of a 3 level memory. In case if it is n level memory, the last level is always assumed to be 1. Why? Because it should contain all the words we are searching for, otherwise it can never be found, isn't it? Okay, and similar way, if you assume that the cost per byte of level 1 is C1 and the size of it in bytes is S1, then what is the total cost of level 1 memory? C1 into S1. Similarly, the cost per byte of level 2 memory is C2 and the size of it is S2, then what is the total cost of this one? SC2 into S2. Similarly, C3 into S3 is going to be the cost of level 3 memory. Then what is the average cost, which is nothing but cost per byte, is nothing but total cost divided by total size in bytes. That is going to give you cost per byte. So average cost is going to be this. Okay, now coming to this level, this arrangement. Now if a word is present in L1, we'll directly get it. Therefore, the time taken should be T1. If the word is not present in L1, right, then you are supposed to go here and get it. But then before that you should decide that it is not present here. That is why the time taken will be T1 plus T2. Assuming that T1, T2 and T3 are the access times of these three levels, I am saying that if a word is present in this level, the time taken will be T1 to read it. If a word is not present here, then the time taken will be T1 to decide that it is not present there, and then we have to go here and again start this search. Therefore, in this case, if the word is not present here, if it is present here, the time taken will be T1 plus T2. If the word is not present here and here, just to decide that it is not present here and here, the time taken will be T1 plus T2, and after that you have to go here and search it. Therefore, it is going to be T1 plus T2 plus T3. Therefore, in this one, what will be the access time will be, if it is present in first level, it is T1. If it is not present in first level, which means 1 minus H1 means that it is not present in first level, which is nothing but miss in first level. If it is present in second level, then the time taken will be T1 plus T2. If it is not present in first level and second level, then the time taken is T1 plus T2 plus T3. Right? Now just compare with this. If it is present in this first level, it is T1. If it is present in the first level, it is T1. If it is not present in the first level, if it is present in the second level, here the time taken is T2, because we are starting the search parallelly. But here, if it is not present in first level, if it is present in the second level, the time taken is T1 plus T2. The reason is, by the time you start searching in the level 2, you should be sure that it is not present in level 1. That is why it is T1 plus T2. Right? So in this one, what will be the best time? Best case in which, or the least time in which you can get a word? The least time is always T1. Right? It's less than or equal to T average. And what is the worst case time in order to get a word? In worst case, you will not get it here. Therefore, you would have spent already T1 to decide that it is not there and it is not present there. Therefore, you would have already spent T2 and it might be present here. Then in that case, T1 plus T2 plus T3, isn't it? T1 plus T2 plus T3. Therefore, this is the worst case time in this case, and this is the worst case time in this case. Got it? Right? And anyway, the cost associated with both of them is same. The cost of the entire memory is same, and this can be extended even to n cases. Here I am dealing with only three levels. You can even extend it to n levels. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.